So currently we'll be doing problem number 6, and it says that 3 students, Kim, Ching Lee, and Jonathan, each have a pack of cards from which they select a card at random. Each card has 0, 3, 4, or 9 printed on it. So part A, it says that Kim states that the probability distribution for a pack of cards is as follows. This is the distribution table, and wants to explain why Kim is incorrect. So the main issue here is just really the fact that the probability over here, when you add up all these values, should equal to 1, just because like once all these are added up together, it should equal 100%. However, that is clearly not the case in here. As you can see, 0.3 plus 0.2 is 0.5, and 0.45 plus 0.35 is 0.8, 0.8 plus 0.5 is 1.3, and that is way too high. So it is impossible because 1 does not equal to 1.3, and once again, the total added value, the sums of all these probabilities has to equal to 1. Now then, the next one states that Ching Lee correctly states that the probability is distribution for a pack of cards is as follows, and it wants us to find the value of k. And so as we already noted above, all these probabilities have to add up to equal 1. So essentially, we have 0.4 plus 0.3 over here, and that equals to 0.7. And what's left is k plus 2k. And so because of that, 1 has to equal 0.4 plus 0.3 plus k plus 2k, or 3k. And because we already know that 0.4 plus 0.3 is 0.7, 1 minus 0.7 is 0.3. And so because of that, with 3k equaling 0.3, this is actually very easy, as you just only divide by 3, and you get that k equals 0.1. And that is your answer for B. Now then, next, it wants us to find C. It shows here that Jonathan correctly states that the probability distribution for his pack of cards is given by the probability is equal to x plus 1 over 20. One card is drawn at random from his pack, and so first it wants us to calculate the probability that the number on the card drawn is 0. So we just need to plug in 0 over here. 0 plus 1 over 20 is 1 over 20, and so that is 0.05. Now, the next one wants us to calculate the probability that the number on the card drawn is greater than 0, and well, 0 is the lowest of 0, 3, 4, and 9, and so because that's just simply 1 minus 0.05, and so 1 minus 0.05 equals 0.95, and that is our answer, and that is all of problem 6.